So we have a number of cases to discuss regarding the projectile motion. So one such case is two projectiles are projected with a complementary angle. That is, if the first projectile is projected with an angle theta, then the second projectile is projected at an angle of 90 minus theta, so that sum of the two angles, theta 1 plus theta 2, is equal to 90 degrees. The condition is that both the projectiles are projected with the same velocity, that is u. So let's find the range and the time of flight and the height, and then what is the relation between all these variables. So first I'm going to write the formula for the time of flight for the first projectile. That is T1 is equal to 2u sine theta by g. And for the second projectile, T2 is equal to 2u sine 90 minus theta. So it is cos theta by g. So this is about the time of flight. So the maximum height reached by the first projectile is h1 is equal to u square sine square theta by 2g. And for the second projectile, h2 is equal to u square cos square theta by 2g. Because for the second, it is sine of 90 minus theta. It becomes cos. The range of the first, R1, is equal to, it's 2u sine theta cos theta by g. 2u square. 2u square sine theta cos theta by g, which is same as u square sine 2 theta by g. For the second one, 2 u square sine 90 minus theta here becomes a cos theta, and cos 90 minus theta becomes sine theta by g. So what we get to notice here in this equation is that even though they are projected with the same velocity at different angles, the ranges are same. So that is the reason why the first conclusion is that the ratio of the range for the two projectiles is 1, or the ranges are equal, T1 into T2. Then I'm going to get this is equal to 2 R by G. So if I multiply these two equations, so we get u square, u into u square, sine theta cos theta becomes R, and then one of the two will remain, and we get the value of G. So that's 2R by G. So that's the product of the time of flight will give you twice the range divided by the acceleration due to gravity. Now regarding the height, the ratio of the heights h1 by h2 will give you sine square by cos square theta, which is tan square theta. And then when we add the heights h1 plus h2, when we add, so sine square theta u square by 2g is common, and then sine square theta plus cos square theta will give you the value of 1. And then if we multiply the heights h1 into h2, so we get r square by 16. If we multiply, we get this value to be equal to r square by 16, and that implies the value for r is equal to 4 root of h1 h2. So these are the various equations related to a projectile where two projectiles are projected at complementary angles with the same velocity. Their ranges are same, and the relation between the time of flight and the maximum height and the range with the height is given in this list. So Do remember these lists. There are again plenty of questions that have appeared in the competitive exams based on this concept. So refer this case where a projectile is projected from certain height h along the horizontal with a velocity u. So what is the time of flight? What is the range? What is the height? All that we can calculate. So when it's projected, it describes projectile motion and it reaches the ground here. So the horizontal distance covered is x, which is equal to the range. The vertical distance that is covered is y, which is equal to the height. So y is equal to h. And since the projectile is projected horizontally, initial velocity along the horizontal, ux along the horizontal is u. And initial velocity along the vertical is 0. So here uy is 0. This vertical component is 0. So to find the horizontal distance, so we need a time. So how to find that time? So we can find that by finding the vertical displacement. So if the initial velocity is 0 along the vertical, what is the time taken by a body when it falls freely? Because acceleration along the horizontal is 0. Acceleration along the vertical is nothing but plus g. So it's a free fall. So therefore, the final velocity on reaching the ground along the vertical is given by Vy is equal to V is equal to U plus AT. Uy is 0. So therefore, A is nothing but G and then T. You can even find this using one more equation, which is Vy is equal to root of 2GH. So this is the vertical velocity on reaching the ground. So here when the projectile reaches, it has vertical velocity as well as it has horizontal velocity. So what is the final horizontal velocity? The final horizontal velocity is same as the initial horizontal velocity, because along the horizontal there is no acceleration because of projectile motion. Along the horizontal there is no acceleration. So therefore, the horizontal component remains same. So if u is the horizontal velocity here, at every instant, the horizontal velocity remains same, which is Vy is equal to. This is not Vy, this is Vx is equal to. And the value of Vy is given by this equation. So how to find the vertical distance, which is h? So h is equal to half g t square. H is equal to half gt square, using s is equal to ut plus half gt square. So from this we can find the vertical distance covered, which is same as y. To find the horizontal distance x, distance is equal to horizontal velocity, which is u, into t, and that x is nothing but equal to r. So from this we can find the vertical height, from this we can find the horizontal range, and from this here we can find the time taken by the projectile to reach the ground. When we know the horizontal component and when we know the vertical component on reaching the ground, how to find the resultant velocity? So this is the velocity with which the projectile reaches the ground. And two vectors are perpendicular, so therefore the resultant is the root of Vx square plus Vy square. The value of Vx here is nothing but u. So therefore that's equal to root of u square plus the value of Vy square So Vy square is here, which is the g square t square. G square t square. You can even write that equation like this, root of u square plus Vy square is the root of 2gh, square of it will give you 2gh. So these are the equation used when a projectile is projected from a certain height along the horizontal. Now, what if the projectile is projected from a certain height, making certain angle above the horizontal? So that is what the next case which I'm going to explain. If the projectile is projected from a certain height, making an angle theta above the horizontal. So let us consider again the height h, which is equal to y. So y is equal to h. And now this time the projectile is projected with a velocity u, making an angle theta with the horizontal. In this case, the projectile moves like this, describes a parabolic path, and then it falls to the ground. So this u, I'm going to resolve into components. So first is ux, and that ux is equal to u cos theta. So this time the horizontal component at each and every point is a u cos theta. So what is the vertical component here? So that will be u sin theta. But since I need the motion of the body in the downward direction, I'm going to consider a downward vector. If u sin theta is the upward vector, opposite of it in the downward direction will be u minus u sin theta. Therefore, initial horizontal component ux is u cos theta, and initial vertical component, which is uy, is minus u sin theta. So these are initial values. If t is the time taken by the projectile to reach the ground, and if h is the vertical distance covered, or h is the displacement because it reaches certain maximum height and then it comes back to the same level, by then the net displacement is 0. So whatever the displacement of the particle is due to this height h. So therefore, how to find this value of h as well as how to find the horizontal distance. So to find the height, I'm going to make use of this vertical motion with the initial velocity minus u sin theta. So therefore, the final velocity on reaching the ground here in the vertical direction is Vy square is equal to uy square plus 2gh. But what is the value of uy? Uy is nothing but minus u sin theta. Square of it will give you u square sin square theta plus 2gh. So that is Vy square. So what is the horizontal velocity on reaching the ground here? That is same as the initial horizontal velocity, because the velocity remains the same along the horizontal, which is u cos theta. So the value of Vx is u cos theta. So from this we can find the resultant velocity, which is V is equal to root of Vx square plus Vy square. So when we square and then when we add here, square it, already there is a square. So we get sin square theta plus cos square theta becomes 1, and then we get only u square. So root of u square plus the value for Vy square. Because of this term, we get 2gh. So this is the resultant velocity on reaching the ground here. So how to find the time taken? To find the time taken, so we are going to make use of s is equal to ut plus half at square format. Here S is the vertical distance, which is h or y. And this uy is the initial velocity along the vertical, which is minus u sine theta, into t plus half g t square. So here you will get a quadratic equation, and you can solve for t to find the time. And once you get the value of t, it's very easy to find the horizontal distance. So horizontal distance x is equal to horizontal component, okay, which is u cos theta, and then into t. So why we are using x is equal to u cos theta and t? Because along the horizontal, the motion or the nature of the motion of the body is a uniform velocity. So that's why we use s is equal to v into t. So using all these equations, we can find the horizontal distance, we can find the vertical distance covered, we can even find the velocity with which the body reaches the ground or the surface of the earth. Now, in the same situation, I'm going to consider, slightly I'm going to modify. In this case, the projectile is projected at a certain height above the horizontal. If the projectile is projected at an angle theta, but below the horizontal, if it is projected like this, below the horizontal, making an angle theta here. In that case, if this is u, the horizontal component will be ux, and that will be u cos theta. And the vertical component will be downward, that is uy, and that will be equal to u sine theta. So the difference between the previous case and this case is that in previous case the value of uy was minus u sine theta, and this time it is a plus u sine theta. So here we get plus value. The rest of the equations remain the same, and all these equations remain the same. Here we are going to get the plus value. So wherever there is minus u sine theta in the previous case, you have to replace it by just plus u sine theta, and rest of all the equations is the same. So these are the three cases of the projectile which are important. Projectile projected from a certain height along the horizontal, and then at an angle theta above the horizontal, and the third case is at an angle below the horizontal. So what is the distance traveled? What is the horizontal height? What is the vertical height? What is the time taken? With what velocity it reaches the ground? All that can be calculated very easily. So for which you have to remember that in projectile motion, the nature of motion of the projectile along the horizontal is uniform acceleration, and the nature of the motion of the projectile along the vertical is uniform acceleration, and along the horizontal it is a uniform velocity. So two more cases related to the projectile, which is again important. So suppose if a projectile is projected and it takes time t1 to reach a point P, which is at a height h, and from that point P further to reach the ground, it takes time t2. So from the point of projection to reach the point P, it takes time t1, and from the point P to reach the ground, it takes time t2. And if you see the diagram here, t1 plus t2. So this has to be time of flight, total time taken by the projectile to complete the path. So that's equal to 2u sine theta by g. And keep in mind, this h is not the maximum height. It is a height randomly that is taken for a particular point in the path of the projectile. So what is the value of that height? The value of that height h is given by half g and then product of this time t1 into t2. In the same diagram, I'm going to measure a few more values. So here we have theta, which is angle of projection. This is the maximum height, which is h. This is the range, maximum horizontal distance covered by them. So what is the relation between the range and the maximum height? So that is r is equal to 4h cot theta. That is, if I bring this cot to the left, I'll get 1 by tan theta, and tan theta is equal to 4h by r. Suppose if I measure this angle, this is called angle of elevation, which is phi. So from this, tan phi is equal to, tan phi is equal to h by r by 2. This is h divided by r by 2. And now if I divide this equation, I'll get tan theta by tan phi is equal to, so we have h by r will get cancelled, 4 by 2 is 2. So that's the relation between the angle of projection and the angle of elevation. So the ratio will be always is equal to 2. So this is again one more important concept, and what you need to remember in most of these diagrams are the final relation between the various variables. So I'm going to consider one more case related to the projectile, and all these equations that we have discussed for a projectile projected on a horizontal plane. Now what if there is an inclined plane of angle alpha, and if a projectile is projected on an inclined plane, so this is the trajectory of the projectile, and the angle of projection is u, making an angle theta with respect to the inclined plane. So here this time theta is with respect to the inclined plane. So the total angle with respect to the ground is a theta plus alpha. Now to understand this, you consider this the plane of the inclined plane as the x-axis, and this is the y-axis. If I consider a point here, the acceleration due to gravity will be always vertically downward, which is g. And with respect to this alpha, if I resolve it, so this will be with respect to the or perpendicular normal to the inclined plane, this will be g cos alpha, and then down the inclined plane it will be g sin alpha. So this will be g cos alpha, g sin. So that means the acceleration due to gravity with respect to the inclined plane is nothing but g cos alpha. So what is the formula for time of flight, which is normally 2u sin theta by g, and now I have to replace that g as a g cos alpha. Time for maximum height, which is h is equal to u square sin square theta by 2g, and again that g has to be replaced by g cos alpha. Now the horizontal range with respect to the inclined plane, horizontal range. So that is r is equal to, normally we use the equation s is equal to ut plus half at square. Distance, horizontal distance. So that is r here. What is the initial velocity with respect to the horizontal here? Horizontal, which is u cos theta. Time taken is nothing but time of flight, and the constant half. So what about the acceleration? So the acceleration with respect to the horizontal here is g sin alpha. But look at the direction. It is downward whereas the direction of velocity here of the projectile is upward. It's moving like this upward. So that's why I have to consider this sign as minus. So it's minus half g sine alpha into t square. So these are the equations to be used to relate the various variable when a projectile is projected from the inclined plane in the upward direction. So one more illustration, one more example for two-dimensional motion is uniform circular motion, where a body moves in a circular path. A body moves in the circular path with constant speed, not constant velocity, with constant speed. So what do you mean by constant speed? It describes equal distances in equal interval of time. And let r be the radius of the circular path. When the particle describes a very small angle, d theta, on the circumference, d theta is equal to ds by r. Or we can even write like this, ds is equal to d theta into r. All the three are vectors. ds, when it is very small, is a vector. D theta is a vector. R is a vector. So therefore, basically, ds is the cross product of d theta into r. What do you call that d theta? That is a small angle subtended when the particle moves from one point to another point, and that d theta is called angular displacement. And it's a vector. The direction of this vector is along the axis upward, which we can get it using the right hand clasp rule or right hand curl rule. The direction of the radius vector is always along the radius outwards. So this is the direction of r vector. And the displacement vector is always tangent to the circular path. And if I divide dt on either side, so rate of displacement will give you the velocity, and the rate of angular displacement will give you the angular velocity, which is omega. So we have again another example for cross product. So this is a linear velocity, which is a cross product of angular velocity and the radius vector. The direction of the linear velocity is same as the direction of the displacement, which is along the tangent. Direction of the angular velocity is same as along the direction of the angular displacement, which is along the axis. So this is the direction of d theta as well as the direction of omega. And the radius vector is always from the center away from the axis of the rotation. This is the axis of rotation. And the magnitude of it, we write it as v is equal to r omega. Because if you want to write the magnitude of it, v is equal to omega r sine theta. Omega and r, they are always perpendicular. So this is vertical, this is along the horizontal, and the angle between them is always 90 degrees. So therefore, v is equal to r omega. The angular velocity can be expressed in terms of the time period of revolution, which is 2 pi by t. So time period of revolution means time taken by the particle to complete one revolution, which is also equal to 2 pi f, where f is the frequency of revolution, number of revolution completed by the particle in 1 second. And the SI unit of it is radian per second. So dimensional formula is t minus 1, because this radian has no dimension. So in uniform circular motion, when the particle revolves in the circular path, there is a continuous change in the direction of the particle takes place. And that can happen only when there is an external force. It is this force which changes the path of the particle continuously. And this force acts along the radius towards the center. And it is called centripetal force. which is given by F is equal to m v square by r, m v omega, and then m r omega square. So centripetal force, without the centripetal force, a particle cannot revolve in the circular path. If the centripetal force vanishes, then the particle will fly off along the tangent. For the revolution of the electron around the nucleus, so there is an electrostatic force of attraction which keeps this electron to revolve around the nucleus continuously with a speed v, and r will be the radius of the revolution, radius of the circular path. And we know that the force is always of the format mass into acceleration. So mass, so rest of the term has to be the acceleration. So therefore, and that acceleration is called centripetal acceleration. Even that acts along the radius toward the center of the circular path, which is given by A is equal to v square by r is equal to v omega is equal to r omega square. So what is the work done by the centripetal force when the particle moves in the circular path? Work done is always given by the format W is equal to Fs cos theta. Force is always along the radius toward the center. Displacement is along the tangent. So what is the angle between them? It's a 90 degree. Cos 90 is 0. So work done is equal to 0. But we also know that work done is equal to the change in kinetic energy according to the work energy theorem. When work done is 0, the change in kinetic energy is 0. That means the kinetic energy remains constant. So in uniform circular motion, when a particle revolves in the circular path, work done is 0, no change in kinetic energy, the kinetic energy remains constant. In non-uniform circular motion, now what do you mean by non-uniform circular motion? In non-uniform circular motion, in addition to the centripetal acceleration, which is also called as the radial acceleration, which is given by AR is equal to v square by r, v omega, r omega square. There will be a tangential acceleration, which is a suffix t, and that tangential acceleration is given by r alpha, where alpha is the angular acceleration. So what is the resultant of these two? So resulting angle between these two acceleration is 90 degrees. So we get the resultant acceleration along this direction, and that resultant acceleration is given by two vectors making an angle of 90 degrees. So therefore that's equal to root of a r square plus a t square. Similarly, the resultant force F is equal to root of Fr square, which is the radial force, plus the force which is acting along the tangent, which is Ft square. In this case, work done by the radial force, which is the centripetal force, work done by the radial force is always 0, because the displacement and the force are perpendicular. But the work done by the tangential force is not equal to 0. Why it's not equal to 0? Because the tangential force and the displacement are along the same direction, so that the angle between the two is 0 degree. So the work done by the tangential force is given by the tangential force into the displacement. So this is the equation to be used when the circular motion is not uniform or non-uniform. So related to circular motion, so we have one more illustration where a string is taken with a mass attached to it, and if it is revolved in the circular path. If it is made to revolve in the circular path. So then, what is the tension which is acting on the string at each and every point? So let us consider this is the lowest point of the vertical motion, and this is the highest point. And along the horizontal, I'm going to consider two more points, which is A and B. A and B. So when this thread reaches a particular point randomly here, which makes an angle theta, at this point, the weight acts in a downward direction, which is mg. So along the radius, the component of the weight which is acting here, this is theta, so this will be mg cos theta. So therefore, when the thread is here, the tension acts along the radius toward the center. And since the particle is in non-inertial frame, the centrifugal force acts opposite to the centripetal force, which is given by mv square by r. So therefore, the net tension of the string at any point or at any instant is given by, I'm going to write here, T is equal to mv square by r, mv square by r plus mg cos theta. So at the highest point, that is at h, so when this stone goes up like this, what is the theta? Theta is 180. Cos 180 is minus 1. So you'll get mv square by r. T is equal to mv square by r minus mg. That's at the maximum height. At the lowest point, theta is 0. So at L, cos 0 is 1. So you'll get T is equal to m v square by r plus mg. So from this equation, what we get to notice here is the tension is lesser when it reaches the maximum height. So when the stone reaches like this, the tension is lesser, it decreases, whereas the tension is maximum when it reaches the lowest point. Now, when this stone reaches here, maximum point, for what is the least tension that is possible? The least tension that is possible is T equal to 0. So therefore, at H, if T is 0, we get mv square by r is equal to mg. M will get cancelled, so v is equal to root rg. So this is the velocity at the highest point which is required so that the particle describes the circular path. That is at the highest point, that is here. Similarly, what is the velocity that is required here? Minimum velocity that is required so that this particle describes the circular path. And to find that, I'm going to use the law of conservation of energy equation. When the particle is at the lowest point, it possesses only kinetic energy, which is half mv/L square, velocity at the lowest point. And when it reaches the maximum height, it possesses the kinetic energy, which is half mvh square plus mg, that is the potential energy, mgh. But that h is nothing but the diameter, which is twice the radius, which is mg2r. mg2r. So half mvl square is equal to half m. The value of vh is root rg, so therefore I can replace it is to be equal to rg here, plus mg2r. So we get m will get cancelled, and then vl square by 2 is equal to So here we have rg by 2 plus 2gr, and we get 5rg by 2. And this 2 will get cancelled, giving VL to be equal to root of 5rg. So minimum velocity at the highest point, which is required so that the particle describe the circular path, to be equal to root rg. Minimum velocity that is required here, minimum, is root of 5rg. Now what happens if the velocity is lesser than root 5rg? If it is lesser than that, then it will not describe the circular path. It reaches certain height and then it falls back. Similarly, we can find the minimum velocity required at this particular point B is equal to root of 3rg. So these are the three velocities at three different points, which is minimum. Remember, minimum velocity. If the velocity is more than that, still it describes the circular path. But if the velocity is lesser than that, then it will not describe the circular path. It reaches a certain point and then it falls back. So these are the three important velocities which you have to remember. So velocity at the highest point, that is essentially is root VH is equal to root of rg. Then velocity required at the lowest point is root of 5rg, and the velocity which is needed here at this particular point becomes the root of 3rg. Now at these 3 points, when the velocity becomes root 5rg, so what is the tension at the 3 points? So we can calculate using this particular formula. So what is the general formula? T is equal to mv square by r plus mg cos theta. So at the lowest point L, at L, T is equal to m. The minimum velocity that is required is root 5rg. So square of it becomes 5rg by r plus mg, and for the lowest point theta is 0, so cos 0 is 1, and this r will cancel. So 5 mg plus mg becomes 6 mg. So when the velocity of the particle at the lowest point is root 5rg, the tension in the string is equal to 6 mg. When the particle reaches the horizontal position, that is at B, tension is given by m. The value of the velocity here is root 3rg, so that becomes 3rg by r plus, when it reaches the position B, the angle is 90, cos 90 is 0, so therefore this term becomes 0 and the tension becomes 3 mg. And finally, when the particle reaches the highest point here, the tension becomes 0. So which we can calculate here using this. Cos 180 is minus 1, and you'll get minus mg, and then value of v square, or the value of v, is a root rg, and then on substituting here, the t becomes 0. So therefore, 3 velocities and the 3 tensions values which you need to remember. 1, velocity here is a root 5rg and the tension becomes 6 mg. Velocity in the horizontal position is root of 3rg. The tension is equal to 3 mg. Velocity at the highest point which is needed is root rg, and the tension becomes 0. And if the values are lesser than this, then the particle will not describe the circular path. It will reach a certain point and then it falls back. So this is again one more important concept of the uniform circular motion. When a particle moves in the vertical plane, it's very important. The particle has to move in the vertical plane, not in the horizontal plane. Because in the horizontal plane, its velocity is always uniform. There is no variation in the tension. The variation in the tension comes when a particle is tied to when a mass is tied to a string, and then when it is made to revolve in the vertical plane. So this entire lesson is very important, as it involves 3 important concepts. One is vectors, the other is projectile motion, then uniform circular motion, non-uniform circular motion, and in most of the competitive exam, so a lot of question appears out of these topics, especially the projectile motion. So that's why practice all this question and then practice more question to make this chapter perfect and thorough for the examination. Thank you.